So this is going to be question number 8 on the discussion, and this question is matchmaker. And so match k is going to be, match k is going to be a function that takes in an integer k, and it's going to return a function that takes in another variable x and like returns true if like all the digits that are k apart are the same. And so pretty wordy, but at the same time, hopefully it makes sense if we look at the dog test. And so looking at the dog test is pretty useful. And so match k called on something is going to return a function. And then using that function, we can pass in like whatever numbers that we want. In this case, we pass in numbers like 10, 10, 20, 10. And then when that function is called on this like these numbers, it's going to check if every like digit like k apart, digits that are k apart like match with each other. And it's going to like return true if it does, all does, and false if like something doesn't match. And so in this case, we pass in like k equals 2, and then we run it through 10, 10. And so 1 is next to 2 apart from this 1 is a 1, and then 2 apart from the 0 is a 0, 2 apart from this 1 is the other one, going back. And so yeah, they all match, and so we're going to return true. But then going back to this other line, so match k of 2, once again k equals 2, and then 2010, what we notice is that 1 right here, well, 2 digits apart is going to be this 2, and they aren't the same digit, so we're going to return false. And then and so along with like k equals 1, 1 is next to 0, 1 apart from 0, and they're not the same, so we're going to return false. 1 apart, well, 1 is the only number here, only digit here, so we have like nothing else to like compare it against, and so we're good to go. 2 and 1, false. 3 is true. They're all like 3 apart. They all have the same digit. And then and so once again, like if you haven't done it already, take some time to like work on this by yourself. Pause the video, take some time. But yeah, let's get started. And so one thing to note about this is that once again, there are 2 function calls. And so the first function call is like returning a function, and the second function call is like returning like true or false. And so because of this, with our knowledge of like how higher order functions work in general, we know that match k is going to like be returning a function. And so the last line, they give us a skeleton code, so the last line definitely has to be return some function. And then so let's think about where we can define our function. And so where we can define our function, it probably makes the most sense to like define it right here, because there's a lot of indents, and in the places that are indented, this while, the if statement, there are no other indentations like little blocks right after like where we can define our def statement. And so this is pretty much the only line that we can define it, so like using like our test taking strategy. But in general, you're always going to see it of this format. It's like def some function in this part, and then like return it in the end. And so let's call this function check. And it says we're going to take in variable x and return true if like etc if it works out. And so we're going to call this parameter x, and it's going to take in like this 1010 right here, or this 2010, and etc. And so going into the body now, we want to determine if like digits k apart match. And so keeping an idea of like how we process numbers, and so the most common way in 618 is going to be the way where we go like n divided by 10 each time, and then we go like n mod 10 to get the digit. And so how it's going to work is like, let's say we had the number 163, divided by 10 each time gets like 16, then 1, then 0, and then modding by 10 on the way through, we get like 3, 6, 1, 0. And so that's going to be how we're going to be processing numbers. And it turns out we can use it for this situation. And so let's put like a very basic thing. This might not be correct, but we can like try it for now. And so like while x, and so x is going to be like a number. And so x is going to keep on being divided by 10 until it reaches 0. And so we want to check if like the current digit that you're at, so like x mod 10, and then we want to check if like the digit k digits to the left of it is also like the same thing. And so the thing is, how do we get like the digit like k digit is like k apart from that digit. And so the way to go about this is if we use the hint, floor dividing by powers of 10 gets rid of the rightmost digits. And so if you think about it, let's say we had 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we divide it by 100, then we're going to get, like, take away the 8 and 9, and we're going to get, like, 1, 2, 3, 4, 5, 6, 7. And if we did, like, 1,000, it would take away the 3 of them, and 1, 2, 3, 4, 5, 6, 10,000, 5, and etc. And yeah, and so keeping this in mind, the way we're going to go about getting, like, the kth digit to the left is that we're going to go, like, x divided by 10 to the power of k mod 10. And so how this is going to work is, like, let's say k is 2. And so 10 to the power of k is kind of telling us how many digits should we remove from x. And so if imagine we had like the number 1, 2, 3 and k was 2. We wanted to check if like the 3 and the 1 are the same. And so that means we have to remove 2 digits before we can access the 1 by like modding it by 10. And so we're going to divide by 10 to the power of 2, 2 being the number of digits we want to like get rid of, and then we're going to mod 10. And so yeah, that's going to be how we're going to get that digit. And then we want to check if they're equal. And then so the thing about it is that the idea here is that we need to check it every single like pair of digits that are like k apart match. And if one of them doesn't match, then we have to return false. But if all of them match, then we're going to return true. And so what our if condition is checking right here is that if one of these digits don't match, then we want to return false. So if one of the digits don't match, then we know that our number doesn't like pass the checker or something, and we want to return false. Meanwhile, if we like get through the entire while loop, what's going to happen is that that means we like check every single pair of digits that are like k apart, and it turns out they all match up with each other. And because they match up with each other, it's gonna pass the checker, and we want to return true right here. And yeah, and one thing to note about this like while loop with like digit manipulation is that if we do like x divided by 10, if we go like while x, we need to make sure that we remove a digit from x each time, because we want to go like 1 to 3, 1, 2, and 1, and like compare a new digit each time. And so in this line right here, we're going to put x integer division by 10. It's like removing the rightmost digit each time, and then yeah. And so one thing to know about this is that you usually see like while x, but the thing about this is like, let's think about like k equals 2, and let's say we had the number like 1, 2, 3, and so 1, 2, 1. And so running through like a code that we have so far, I might not use this line. You can if you want. I'm going to go over the solution right here that actually does use it. But what's going to happen is that we check like 1, 2, 1. 1, we check with the one that's like 2 apart. It's also 1, so we're good to go. And so we take out the 1, and we want to make the same comparison. And we're still going to go through this while loop. And so we're checking with 2. But the thing to know about this is that there is no digit 2 to the right, 2 to the left of this 2 right here. And so what's going to happen is that we're going to check if x mod 10, so that's 2, is not equal to x divided by 100. And so divided by 100, this 12 divided by 100 is going to be 0, and we're going to get the digit 0 out of it. And so 2 is not equal to 0, so we're going to return false. And so the thing about this is that, yes, 2 is not equal to 0, but we don't need to be comparing this 2 with any more digits, because we kind of like imagine like have an imaginary 0 back here. But since 2 doesn't really have any digits that are like 2 apart from it, there is no reason to check this 2, and we can like kind of just stop there. And so we have to change this while condition to stop for it. And so to address this issue, we want to see if there is like a leftmost digit, like that's like k apart. And so in the case of like 1, 1, 2, there still is like a number. Now we need to check like the 2 and the 1. And so notice how if we did like 1, 1, 2 divided by 10 to the power of k, this is going to become 1. It's like 1, 1, 12 divided by 100 becomes 1. And then, but if we did something like 99 divided by 10 to the power of k, we're going to get 0, because 99 is less than 100, and there is no digit 2 to the left of this 9 right here. Like, let's say it's 8. But yeah, and so the condition that we want to check instead of like while x is we want to check while x divided by 10 to the power of k. And so if this condition is true, that means that there is a digit like k to the left of the digit that we're currently looking at, and we can like go through this check. But if we go below this threshold, so like in this case it's like below 10 to the k, we go to like 98, that means that there is no digit that is like 2 to the left of the current digit. And so because of that, we can stop right there and we can return true. And so yeah, this is kind of going to be the function. And if we run the doc test, oh, and one thing to note is that line 125, I said return some function. We want to return this check right here so that we can call it. But yeah, if we run the doc test, hopefully it returns true. Yes, it returns true. And so yeah, if you have any questions about this, I kind of botched the explanation a little bit. Feel free to like email me or like DM me on Discord, all of that. But yeah, if we were to go over, so this is the solution I just went over, the one I wrote, where we like divided by 10 each time and then checked it. But another solution that you can do is that we can say like I equals 0. And then I equals 0 kind of tells us like we want to check like the zeroth position digit with like the ith position digit with like the ith plus kth position digit. And so in this case, let's say I equals 1, we will be comparing the 1 with this 2 right here. And so similar conditions, if 10 to the power of I plus k is less than x, so if there is a digit like k to the left of the digit that we're currently at, then we're going to get the ith digit and the ith plus k digit. And so this is like a little bit different from this one. I think this one is much simpler to understand, but if you just take a look at this, hopefully it makes sense. If it doesn't, don't worry about it. You only need to do it like one way. And so if you did it this way, that's cool. But yeah, so we're going to get the ith digit right here. It's like x divided by 10 to the I, getting rid of like the first ith digits and then modding by 10. And then to get like the ith plus k digit, we go like 10 to the power of I plus k. We divide x by that, and then we mod by 10. And if those aren't equal, then we want to return false. And then we're moving the position of the digit by going like I equals I plus 1. So we're first checking the 0th position digit, like the 1th, the 1's digit, then we're checking the 10's digit, 100's digit, etc. But yeah, and once again, once we go through this entire while loop, we're going to return true because everything matches up. But yeah, let me know if you have any questions, and have a great day.